Live from the BBC, The Naked Scientists.
Welcome to this week's edition of The Naked Scientists with me, Chris Smith, and with Kat Arney.
Hello.
This week, a show not to be sniffed at or even sneezed at, because we're talking about the science of allergies and how the immune system works, and also parasites, because scientists think that parasites and the fact that they're able to persist in the body for a long time and have therefore evolved clever methods to outwit our immune system might hold the key to some of the future drugs to tackle allergies. If you'd like to join in tonight's discussion, the phone number's 08459 25 2000. Our text number's 07786 20 1960, or you can email chris@nakedscientist.com.
And also coming up on the show, we bring you more from the world of science. So Chris is going to be telling you about a potential new way to treat haemophilia, a new coating for metal that will stop it going rusty in the rain. I'll be telling you about a more interesting new connection between music and maths, and whether the humble paracetamol could prevent cancer. Chris.
And we've also sent Derek up a mountain in Tanzania to make some ugali. More on that shortly. That's our kitchen science for this week. It's kitchen science at a distance. And also, here's my quiz question for you. If you think you know the answer to this one, you could win yourself, we have to give away this evening because it's an allergy show, 2 chirokinetic therapy sessions at David Stevens Harley Street Surgery in London. So this is if you have allergies or you know someone that has an allergy, then they'll try this therapy, chirokinetic therapy, in London at Harley Street, and we'll follow you up and see if it actually works on you. The question tonight, what geographical feature does every continent have an example of, except Europe?
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Well, there's news from the world of cancer this week, because scientists at Athens University have published a study that shows that paracetamol use could actually prevent ovarian cancer, or certainly reduce the risk of the disease. This isn't a new study. What the researchers did is kind of pooled all the results of a large number of studies that have been done into this. It's called a meta-analysis, and it's quite an accepted technique now. So they pooled together 8 studies, which came to a total of nearly 750,000 women studied. So it's a big number of women, very powerful. And they found that regular paracetamol use could actually cut the risk of ovarian cancer. This is quite interesting because ovarian cancer is something that's known as the silent killer. It's very difficult to detect, and it does kill quite a lot of women in the UK, around 4,000 women every year. So it would be very interesting if something as humble as paracetamol could help to prevent the disease. But there are side effects associated with long-term use of paracetamol and
kidney
drugs like
problems
that.
And liver problems.
Exactly. So it's a bit of a toss-up. So, if you're worried, don't go rushing out taking loads of paracetamol, because that's not very good for you. So hopefully they'll be able to do a proper trial now. Now they know what they're looking for. But also Cancer Research UK are actually funding a study using a blood test and an ultrasound screening to detect ovarian cancer. So,
got any clues as to how it has that effect?
How paracetamol works? No. Well,
in terms of its impact on ovarian cancer, obviously.
In terms of its impact on ovarian cancer, there's a lot of work being done on the ability of drugs like paracetamol to affect sort of cell death and things like that, something called apoptosis, which is how cells die normally in the body. And cancer cells, as well as being cells that are growing too much, are cells that don't really know they should die. So paracetamol might be involved in this kind of pathway. Maybe.
Because aspirin, as well as having this amazing impact on pain relief and its ability to prevent heart disease and strokes, also has an incredible impact on cancer, doesn't it? People who take lots of aspirin regularly have a reduced risk of bowel cancer and also upper GI cancers, esophageal cancer and lung cancer.
Exactly. That's actually another Cancer Research UK trial that we've been funding lately. So,
and it also staves off Alzheimer's disease, which is nice, alongside turmeric. So lots of people in India who eat a lot of turmeric also have low levels of Alzheimer's. We believe that might be the link, although it's very hard to prove because it's difficult to know what the doses are. But onto something completely different, which is the subject of rusting and metal corrosion. Now, this is a major problem in the aerospace industry, because aeroplanes are built of aluminium because it's extremely strong but very, very light. And another useful use for aluminium, because it's strong and light, is actually in power cables, because most people think power cables on pylons and things are copper, but it's too heavy and it's also expensive. Aluminium, whilst being expensive, the payoff is very, very strong but very light. You don't need as tough a pylon to support it. But how do you stop your aluminium going off? Well, a group of researchers in Germany, led by a guy called Helmut Mowold, and he works at the Max Planck Institute for Colloids and Interfaces in Potsdam. And what they've done is to produce a very clever system where you have a coating which only releases a corrosion inhibitor wherever it's damaged. And this is what they've done. They've taken some tiny glass beads. They're 100 nanometers. That's 1/10,000th of a millimeter across these tiny beads. And they've given them 2 coatings of 2 different polymers. And one of the polymers is a substance called polyethylene imine, and that has a sort of positive charge on it. And the second coating is called polystyrene sulfonate. And because that's negatively charged, it sticks to the positively charged polyethylene imine they put on first. And sandwiched between those 2 layers is the corrosion killer, and it's a substance called benzotriazole. And so it's immobilized between these 2 layers and kept out of harm's way. And you mix this whole lot together in a gel called zirconium oxide and coat the metal with it. And wherever it gets scratched or damaged, the silica balls get ruptured or broken open, and this releases the benzotriazole, and the result of that is it comes out and stops the metal corroding. And they've done 2 very simple experiments. They scratched pieces of aluminium in air and underwater, in seawater in fact, and they were able to demonstrate that scratches of quite a significant size, up to 0.1 millimetres, which is actually quite a big scratch, especially in the context of something like an aeroplane, were completely prevented and protected from corrosion. And so now what they're trying to do is to play the same trick on iron and steel, because it might be possible to protect our cars in exactly the same way.
I think it's too late for mine. My car's complete.
It's looking a bit scruffy.
It's a complete rust bucket, my car. Yeah. Anyway, researchers at the University of Princeton have been looking at music in a very different way. Normally you think, well, you listen to music with your ears, it sounds nice or it sounds horrible. But actually, this researcher called Dmitry Tomosko has been looking at music in a very different way. He's been doing mathematical modelling with music. Now, the structure of music is you have a melody and you have chords underneath it that provide your harmony. And, nice classical music, bit of Mozart, stuff like that. It has a very pleasing to the ear sort of structure of the chords and the melody. Whereas modern music can sometimes sound very dissonant, very hard to listen to, because the chords don't make a nice progression and a nice sound.
Like rap?
No, not like rap. I mean, like modern, your sort of your Schoenberg and your Weber and that kind of stuff.
Fair enough.
You're just uncultured, Chris. Anyway, so what Tomosko's been up to is creating mathematical, 3-dimensional mathematical models of music, so he can plot where the chords are in a mathematical space and then see how the relationship works between them. And for example, if you take a piece of Chopin and map where the chords are, you can see that it sounds, the chords are quite straight harmonic chords, but it sounds a bit weird to the ear. And then he can tell that that's because the chords are quite close together in this area of geometric space, whereas other pieces pieces that sound very, very odd, they have their chords spread out all over the place in geometric space. So this is a tool not only for mathematicians, but also for musicians and composers to help them understand why something might sound good or why something might sound really weird.
So given that you've got this formula for what sounds good, is it possible to write a computer program that can then write music that sounds good?
Well, I think there's some of those out there already. Have you heard Britney Spears stuff?
Yeah, no, it's quite good actually. Only joking. I don't need the people in white coats to come. Look, this is an interesting story. Talking people in white coats, haemophilia, and this affects about 1 person in 5,000 if they're male. And as we discussed last week on the show, we're talking about the X chromosome, because the gene for haemophilia, one of the 2 diseases that causes haemophilia, is on the X chromosome, and men only have 1 copy of that chromosome. We're more likely to be affected than women are, which is why you tend to see men with this bleeding disorder. It's actually caused by the lack of a blood clotting factor called factor 8, which is almost like a linchpin in what's called a clotting cascade. So when you injure yourself, all of these proteins are switched on in turn in a cascade. One activates the next, and that activates the next, and activates the next, and it culminates in the formation of a blood clot. And factor 8 is what's missing. It's the key part of that cascade, and it's absent in these people. And it's fairly easy to treat. If you have inherited the problem, then injecting fresh factor 8, which can be made synthetically these days, can overcome the problem. But in about 30% of people, the body recognises this injected factor 8 as a foreign substance because you don't make any of your own. And so it assumes that this is something it has to react against. And so the body makes antibodies, referred to as inhibitors, against the factor 8. And this stops it working. And this can push the cost of treating someone with haemophilia into the millions, because you have to start using other extremely expensive agents that cost an absolute fortune. So how can we get around the problem? Well, a group of scientists who are working at the Medical College of Wisconsin under the guidance of Robert Montgomery, and that's in Milwaukee in the States, they came up with the idea of of tackling the problem using platelets. Now, platelets are what are essentially bits of cells. There are stem cells in our bone marrow called megakaryocytes, and they bud off and they make little pieces of their cell membrane available in the bloodstream, which are these platelets. They're not actually proper cells, they're just bits of the cell. What the researchers did was to take the stem cells that make those platelets and add a healthy copy of this factor VIII gene to them. And this is in mice that have been genetically engineered to have this particular form of haemophilia. And when they added this gene and then put these stem cells back into the mice, they found they could cure the mice from their haemophilia. And the reason what was going on was that the platelets were going around in the bloodstream, keeping this factor VIII hidden inside the platelet, so the immune system couldn't see it. And then whenever the platelet was needed, wherever there was an injury to the blood vessel wall, for example, then the platelet would activate, which is what platelets do anyway, and pump out the contents of the platelet, including the factor VIII. And there it was, made on demand where it was needed. And this was able to massively overcome any of the problems because of antibodies that people with haemophilia have developed. So what they're hoping is that this might be possible in people who have haemophilia. And this, if you can establish sort of long-term transduction, in other words, expression of this factor VIII in these platelet precursors, it might be possible to cure people with haemophilia in future.
The Naked Scientists, supported by the Wellcome Trust.
And now it's time to head stateside for this week's Science Update, where Bob Hirschon and Chelsea Wald take a look at a nasal spray that could put an end to marital strife and how your child's drool could reveal its stress levels.
This week for the Naked Scientists, we'll be exploring your emotions and how your body chemistry regulates and responds to them. First, Chelsea has some new findings on the so-called love hormone and how it could help even when you're not feeling especially amorous.
In your brain, oxytocin plays a vital role during sex and emotional bonding. And according to Emory University behavioral scientist Beate Ditzen, it could even help during domestic spats. At the University of Zurich in Switzerland, she and her colleagues monitored a stress hormone in couples discussing unresolved conflicts. Couples who snorted an oxytocin nasal spray beforehand produced significantly less of the stress hormone. They also talked more openly about their feelings.
I interpret that as very positive, that oxytocin made them overcome their avoidance of this self-disclosure during a conflict.
She says the ultimate goal isn't to medicate marriages, but to understand how natural fluctuations in oxytocin can affect a relationship.
Thanks, Chelsea. Well, one thing that can stress a relationship is incessant screaming, crying, demanding. No, we're not talking about your spouse, but your baby. And as tough as it is for you to listen to, it's even tougher being an infant. Could that crying mean that your child is suffering from debilitating stress? Now you can find out with a simple drool test. It measures levels of alpha amylase, a digestive enzyme found in saliva. Increases in the enzyme have been linked to stress in adults, and now a team led by Doug Granger, director of the Behavioral Endocrinology Lab at Penn State University, found that babies also produce more of the enzyme in stressful situations. In older children, higher alpha amylase levels were linked to social problems, academic difficulties, and even physical illness.
We are hoping that measures like this one will allow us to determine who is more resilient and who is more at risk of some of those negative consequences of stress.
And the ease of a saliva test could lead to new insights and earlier interventions for droolers of all ages.
Thanks, Bob. Next week we'll learn about eggs that can run away from predators. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society. Back to you, Naked Scientists.
Thanks, Bob. If you want to hear more from the Science Update team, then check out their website at www.scienceupdate.com. And that was dedicated to Ian. His girlfriend, Chelan, has emailed us in from the show. She's in Oregon, and she says she's really thrilled with the podcast. She discovered it last fall and has been an enthusiastic fan ever since. In April, she's a graduate student in America, and she drove with a car full of fellow graduate students from the University of Oregon to San Francisco to attend a meeting, and they listened to 10 hours of the Naked Scientist podcast on the way.
So, and I thought I needed help. Yeah.
Exactly. You win a prize for dedication. And she says, Gillian Weaver says, my boyfriend is as much of a science geek as I and relishes the show. Can we dedicate science fact, science fiction, or an update to him? So, Ian, here you are. This is a shout out to you. We dedicated the Science Update to you this week.
My challenge for you this evening was if you can tell me what geographical feature does every continent have an example of except Europe. We've heard from Matt in Benfleet, he's definitely on the right lines, as is Leslie, who's on the road driving home, and Brian in Lower Somersham. Do you know the answer? 08459 25 2000. And whilst you're on the phone, if you have a question about anything to do with allergy, the workings of the immune system, how to prevent allergies from forming, and also how to treat them, or parasites, worms, anything like that, 08459 25 2000 is the phone number. Now, I've got an email here from Christopher Levins, who is listening to us in the States. He says, I wanted to let you know how much I enjoy your weekly podcasts. I'm an organic chemistry graduate student at the University of Pittsburgh in Pennsylvania. Pittsburgh, sorry. I like to listen to your programme on my ride to and from the lab and whilst doing the laundry, excitingly enough.
Rock and roll.
That's right. Now, you mentioned last week that the fat in the human body could be used to make 7 bars of soap, and I thought something you might find really interesting came up. At the Mutter Museum in Philadelphia, which is run by the College of Physicians, they have an incredibly bizarre and fascinating display of incredibly bizarre and fascinating things. One of the most famous exhibits is the Soap Lady. This is the corpse of a woman who died from yellow fever in the 19th century. When scientists studying the disease exhumed her body, they found that all of the fat in her body had been saponified, broken down into glycerol and soap molecules, because of the chemistry of the soil around her grave. Because she's made of just bones and soap, her corpse is preserved and on display at the museum. So if you ever get to Philadelphia, the museum is definitely worth a visit. Best of luck with the show. Sincerely, Christopher Levin. So thank you for that, Christopher. Fantastic. Really, really like that one.
That's kind of cool, but kind of weird.
What else have you got, Kat? You got some other letters.
We have an email here from Hasib Anjum, who's in Pakistan. Have we had someone from Pakistan before?
No, I think it's the first.
I don't think so. All right, well done, Hasib. You're the first one from Pakistan. And he's just started listening to the show. He says he heard the episode where someone was asking about blue bottle stings and urinating on them for the cure. I think was it jellyfish we were talking about a couple of weeks ago. And he said that he and his friends went to the Karachi beach this weekend, and a lot of them got stung. The lifeguards told them to rub onions on the sting and to drink something hot and avoid going back in the water, and it all worked. So apparently everyone who goes to the beach in Pakistan takes onions and tea. Any idea why it works? Chris, why do you think it works?
I haven't got the clue, but I have got an email here from Kat, and she writes under the email pseudonym United Girl 24, and she says, I'm wondering if you could tell me why a chili is called a chili when it's hot. When it's so... don't know, actually. It's an interesting question. Does anyone at home know why is chili referred to as chili when it clearly isn't? I can tell you how it works, and it's because it's got an agent called capsaicin, which is an oil-soluble molecule locked up in the skin and flesh of the chili, and it locks onto the same nerve fibres in the mouth or wherever you put it on the body that signal heat and temperature, and it fools those nerve fibres into thinking that you're hotter than you are, and that's why it feels like it's burning. And then there's an interesting sort of sideline to this, Kat. Do you know of an animal that's totally insensitive to the effects of chili?
Dogs?
No, chickens, actually.
Really?
Yeah.
Do they not have the receptor for it?
No, they don't, and you can feed a chicken vindaloo and it's perfectly happy. In fact, I did this to one of my chickens and it died. And I took it to the vet and he said, I think it slipped into a coma. Sorry about that. Now, look, it's time for this week's Kitchen Science, and over the last few months we've done Kitchen Science from Kettering, Norwich, Downham Market, in fact, right across the eastern region. But how about this? Some Kitchen Science from East Africa, rather than East Anglia. Derek Thorne, who's our normal Kitchen Science reporter, has actually been away to Tanzania recently, and while he was there, he managed to find out about the science that's going on in kitchens in Tanzania, and here's what he uncovered. Derek.
In Tanzania, there is one particular food that no one could live without. But it's not chocolate or chicken or any kind of fruit. It's a curious substance called ugali. Now, being the kitchen scientist that I am, I couldn't resist finding out more about this stuff. And I began by speaking to a Briton called Felicity Thompson, who's lived in Tanzania for a total of 4 years. So, what is ugali?
Ugali is a maize meal, kind of white, flour-based substance, looks a bit like cement, and perhaps some people think it tastes a bit like cement. It's the staple food of Tanzania.
And what are your memories of ugali? When did you first taste it?
I first tasted it when I was volunteering in Tanzania about 5 years ago, and my first impression was not great. I had it perhaps with sauce that was not so great, and basically with ugali it's all about the sauce.
OK, so tell me more about the method of eating with ugali then. What do you have to do? OK,
well, with ugali you get a lump on a plate, and you basically use your fingers, your right hand, and you grab a bit and you start rolling it up in your hand, and then you make a little sort of boat with it in order to scoop up whatever you're eating it with.
So, it's white, it's thick, it's floury, and it's very, very popular. You'll find ugali being eaten all over Tanzania, and what's more, it's now found its way into popular culture. Check this out, a Tanzanian rap artist called Juma Nature rapping about how everyone in the country loves ugali. But despite being so popular, it seems we outsiders find this stuff rather hard to appreciate. So how is it that ugali can be enjoyable?
Well, ugali is never eaten by itself, but the texture and the sort of weight of it, if you put that together with a really tasty sauce, maybe a curry or like a tomato-based sauce or even beans with coconut, it is the perfect combination, basically.
And have you ever cooked ugali?
It's tragic to say, but I haven't. I've been here for 4 years and I've never cooked ugali.
Felicity Thompson speaking there, and I should add that I too have never cooked ugali. So, while I was in Tanzania, I felt I had no option but to find out how it's cooked, and to look into the science of ugali as well. So, here it is, some kitchen science from Tanzania, courtesy of Chelu George, who runs a cafe called Best Snacks in the town of Iringa. She kindly let me into her kitchen and showed me the things you need to make ugali. Firstly, about a litre of water boiling on the stove. Secondly, about 200 grams of maize flour, which is basically corn flour. And thirdly, a bowl full of cold water. So, listen up if you fancy trying this at home. This is how you make ugali.
We start now to put the dry flour into the cold water. We stir it with a wooden spoon.
So the flour is in the cold water there, so it's not really dissolving very well. But I suppose, yes, it's kind of becoming like an emulsion, quite a thick emulsion, isn't it? There's kind of bits of flour in there.
It has to dissolve well so that it doesn't give lumps. Then we now pour this mixture of flour into the boiled water.
So that's gone into, let's say, a litre of water, which is bubbling away on the stove, and it's rather thinner now, but I can see that there actually are no lumps, so that's gone very well. OK, and so what now?
To stir it until it boils again.
So you dissolve the flour in the cold water as best you can, and then pour that mixture into the boiling water. And after a couple of minutes, the mixture starts getting thick. Now, does this process remind you of making a more familiar food? Well, a few months ago on Kitchen Science we made gravy, and this is really very similar. Each granule of maize flour contains starch molecules, and these molecules, which are normally long and thin, are actually bunched up and tightly packed. When you heat the granules in water, however, they swell and burst, and the starch molecules can stretch out to their full length. Since there are so many in the mixture, they very quickly tangle with each other, and this is what makes it go thick. The main difference between ugali and gravy, though, is that you heat ugali for longer to make it even thicker. You could call it an uber gravy or something like that. Anyway, back in the kitchen, the mixture is boiling and we're about to add more dry flour to it.
We put only 2 big spoons of flour and start stirring it until it becomes thick.
OK, so we're going to add more flour then to this rather thicker kind of porridge-like mixture we've got bubbling away. In it goes, so that's 1 spoon. And the second. OK, so that's actually getting pretty thick, and the bubbles, let's get a bit of audio of that. They're actually pretty thick bubbles you can hear. There you go, that's like a potion bubbling away on the stove there. Fantastic.
So
OK.
I start stirring it until it becomes much more thick.
And that has actually gone really thick now. I mean, that's not really a liquid anymore. That's kind of looking like mashed potato.
So we continue stirring it until all the lumps are finished.
Yeah, so we can smell now the ugali, which is just sat there. It's a big lump of, I suppose it's just thick porridge-like stuff. It's very, very thick, isn't it, though? It looks like mashed potato, but is thicker than that. Shall we have a try?
Yes, we can try now. When you take a piece of ugali, you don't have to take it from the middle because it is very hot in the middle.
OK, right, well, here we go. And as I know from being in Tanzania a little while, it is the right hand that you eat with.
Yes,
and,
we use the right hand to eat it.
So I'm just going to try some. Nom. And there it is. Very good. It's a bit dry to have on its own, but... I mean, do you enjoy eating ugali on its own?
No, it is enjoyable when it is cooked nicely, but it is not nutritious.
And I know that you've been making this ugali while I've been asking you various questions. So is this good ugali, or I mean, did I distract you?
It is good ugali.
And I can vouch for that too. So there it is, that's how you can make ugali. And now I'd like to know whether you at home can do it. It's not hard, you just have to stir corn flour into boiling water until it gets really thick. And, as always, please take care with any boiling water. Please tell us how you do, and also tell us what it tastes like. Do you think ugali could catch on here? The number is 08459 25 2000, and you can email chris@thenakedscientist.com.
Well, thanks very much, Derek. Next week, Derek will be back in the UK and finding out how sun cream protects you from damaging UV rays. And that's because on next week's edition of The Naked Scientist, we'll be finding out about the science of the sun, we'll be finding out about nuclear fission and nuclear fusion and how nuclear energy works in general, and also finding out why some people burn more in the sun than others. And if you have any questions for us on that, please send them to me by email this week, chris@thenakedscientist.com, and let me have them in time for next week's programme, and we'll try and include them. I am asking you this evening, what geographical feature does every continent have an example of, except us here in Europe? We've heard from Liz in Norfolk. She thinks it's a coral reef. Not quite right, Liz.
Not quite right. And here we have an email, speaking of coral reefs, from Captain Jan Salm, who is on the MT Sathania, floating somewhere in the Red Sea. Hello, we've never had anyone on a boat before, I don't think. And he likes listening to the podcast via the internet. It's a great programme which whiles away the empty hours at sea. He managed to download a year's worth of programmes before leaving home. And he's just reached the end of our programme's broadcast in March, so... Well done.
Doing well.
Thanks for listening.
When he next docks, there'll be another sort of surge in bandwidth. And that's the Naked Scientist podcast, incidentally. If you miss a programme, you can download it and listen to it at your leisure. You just go to nakedscientist.com. That's our website, and you follow the links there to the download. It's The Naked Scientist, Dr. Chris and Dr. Kat with you this afternoon. And we're talking about the immune system very, very shortly, and also allergies and parasites. And if you'd like to join in with the discussion, you can email chris@nakedscientist.com.
Stripping down science.
Okay, let's do it.
The Naked Scientists.
It is The Naked Scientists, and we're talking this afternoon about the science of allergies. And from the University of Lincoln, here's Professor Carrick Sewell. Hi, Carrick. Thank you for joining us.
Hi.
Can we just get to the bottom of this? Because allergies are obviously a manifestation of how the immune system works. But what actually is the immune system?
Well, the immune system isn't one thing, and I think we use the term immune system just for a shortcut to avoid saying immune systems, because there are loads of them. You can find them in everything from plants to insects to all sorts of animals. And through evolution, we've adapted to cope with the onslaught of pathogens. All the germs, viruses, everything that tries to invade and kill us, we've evolved to deal with in various ways, and our immune systems are the tools that the body uses to do that with.
What are the bits and pieces that do it? What has it got in its arsenal to deploy?
Well, if you draw the immune system out, it makes the underground map look basic. So there's an awful lot to it, but there's two key things which really help picture it in your mind. The first is that the immune system needs cells, and there are a variety of cells of the immune system. Many of their functions are to go round, find a pathogen, and ingest it and kill it in some way. There's a variety of ways they can do that. But the clever part of the immune system is the eyes of the immune system. And we often say the immune system sees a pathogen, but in fact it hasn't got any eyes. And even if it did, it's dark in there. So the immune system needs detectors, and the commonest type of detector everybody's heard of but doesn't really know what it is antibodies. And in our bloodstream we have literally trillions and trillions of antibodies against almost anything conceivable.
But what actually are they? Because most people, when you say an antibody, people think of something that's alive in some way. And I remember being at school when someone had written on the blackboard, enzymes are not alive, they cannot be killed, they're bits of protein.
Well, antibodies are other bits of protein as well, and they're made by one of the cells in the body, the B cell, and they stick to pathogens very, very specifically. So an anti-polio antibody will only stick to polio, an anti-salmonella antibody will only stick to salmonella. But all antibodies come in one of 9 flavours or isotypes. And they, if you like, are the payload of the missile that is the antibody. So just as a bomb may be, I don't know, high explosive or armour-piercing or whatever the captain's chosen that day, antibodies come in these 9 different flavours, and the effects of those are very, very different.
So what are the antibodies responsible for allergies and things like that then?
The antibody which causes allergy is called Ig, which is short for immunoglobulin, IgE.
So that's the nasty.
That's the nasty one, but it's also probably an essential one. And that has a unique property. An IgE can recognise pathogens, but its payload is to stick it to a cell called a mast cell, like the mast on a ship. And the mast cell is stuffed full of histamine.
But why have that? Because most people are only too aware of how nasty histamine is when it gets out of that cell. So why do we have it? What's its role?
It's very poisonous to parasites.
Why? How does it work?
I wish I knew.
So you have these cells that are like miniature hand grenades waiting to be detonated, and they have an IgE sitting on their surface. So what goes on to make that cell discharge that histamine? How does that work?
Well, the mast cell will be covered in IgE molecules against all sorts of different targets. It isn't one mast cell is against this thing, one mast cell against that thing. Each of the mast cells in your body, and they live under the skin and in the blood vessels, each of those mast cells is coated in different IgEs. If a piece of pathogen or a piece of other protein comes past that mast cell and sticks to several IgE molecules at once, that sends the signal to the mast cell, OK, burst now and discharge all your granules containing mainly histamine, but also loads of other noxious molecules.
So that's what gives us the response, the sort of the swelling, the hives, weepy eyes, snotty nose.
Probably quite a useful response if you think about the type of things that are happening. Many of them flush clear the area where the allergen, the thing that causes an allergic response, has come into the body.
But the key question, Karok, must be, everyone's got these IgEs, haven't they? So why is it just me that when I walk into a field of corn at this time of the year, I get streaming eyes and feel a bit of a cough coming, and it's very unpleasant, but Kat might be fine?
Well, I'm not.
Okay, she's not fine. You might be fine, but how does that work? And
it's not just you. It's about 20% of the population these days in the UK accidentally seems to make IgE flavour antibodies against harmless things, like pollen, as you say, rather than the IgG antibodies, which the body mainly uses for fighting off bacteria.
So if someone's allergic, do they just have more of these IgEs, or are they directed against things they shouldn't be? Do they recognise and pick up stuff they shouldn't?
All the antibodies in your body are very ultra-specific for a particular target. So you will have some IgE in your body against all sorts of things, but if you have enough of it against a particular pollen, and you encounter a cloud of that pollen, it will set off the mast cells in your eyes and your nose and where you've breathed in those nasties.
Oh, lovely. I think we've got a call from Raymond now. He's got a question about allergies.
Hi, Raymond.
Hello.
Good evening. Welcome to The Naked Scientist.
Hello. Yes, thank you.
What would you like to talk about?
Well, rhinitis. I suffer with it, and I have done for a long time. And originally I was treated for hay fever for many years until, quite by accident, it was discovered that I'd had rhinitis. I went for an X-ray for something else, and the doctor discovered that rhinitis was prevalent in my body. But nobody seems to know if there's a cure going for it yet.
So, Karok, first of all, let's put Raymond's mind at rest. What is rhinitis, and where do we stand on actually treating allergies?
OK, well, rhinitis is inflammation of your nose, and hay fever is one of the types of rhinitis. So hay fever's a bit of a stupid name, but it's one that has stuck. But there's no hay and there's no fever involved. But it's lasted over the decades, and it's what people call it. Inflammation of the nose can happen for lots of different reasons, but if you are allergic to a particular sort of pollen, say, then you may have allergic rhinitis. And it means that when you inhale the substance you're allergic to, it triggers all those running and itching and sneezing symptoms in your nose.
What about doing something about it? What can we do drug-wise to help? Nose sprays, that kind of thing.
they can play an extremely important role, but the first thing to do is to diagnose exactly what type of rhinitis your caller has. And for that purpose, they may need to see an immunologist or allergist, or someone like an ENT surgeon who specialises in allergy of the nose. And they would undertake a variety of allergy tests to see what are the things which are causing the problem and how can he avoid them the best. The next treatment is to actually reduce the symptoms in the nose, and there are lots of drugs for doing that. They involve some sorts of nasal sprays, typically steroid nasal sprays, which are much safer than steroid tablets and don't have the same side effect, and antihistamines are also a very common treatment. But there are other drugs too.
Raymond, does that help?
It does, thank you. I am on steroid, thing called Centaurus. But it relieves it, but it just keeps on coming. I have it all the year round.
Well, unfortunately, you just have to suppress it,
yes,
rather than unfortunately cure it, because we're not really very close to doing that.
I have every sympathy for you. I come from a family of snuffly people.
You've experienced it as well, then.
Yeah.
Quick go at the quiz, Raymond.
Yes, all right then.
If you arranged all of the ants on Earth, the insect, the ant, nose to tail, you could produce a line of ants 126 light years long. Do you think that's fact or fiction?
I'd say it was fact.
Staggering. Chris has had nothing better to do with his life except do the maths. He thinks that there are 300 million trillion ants on Earth. That's 3 followed by 20 zeros. An ant's about 4 millimetres long, so you could produce a column of ants 12 followed by 20 zeros millimetre long. So light travels at 300 millimetres a second. It would take a beam of light shone along this column 126 years to travel from the first ant to the last ant. Have you got nothing better to do with your life, Chris?
I'm afraid not. No, so, well done, Raymond. 1 out of 1 so far. Next question. The average person in the UK eats 10 kilos of chocolate every year. Do you think that's fact or a bit ambitious?
That's probably fact as well.
You're absolutely right, yep. It's 9.3 kilos of chocolate per person per year, and I think most of that's me.
Well done, Raymond. You're in the lead at the moment. Thank you for a great question too.
Laying the facts bare, the Naked Scientists.
So, Carrick, let's resume our discussion about allergies and things. So we've got to the stage of understanding how these mast cells, when the IgE is activated by something, provokes the symptoms. What do we think is actually going on to make that happen in the first place? Do we understand anything about why some people do develop this mess-up of the immune system and others don't?
Well, we understand parts of it, and the picture's beginning to come together, but it's a rapidly developing field. One of the key things is, how does your immune system decide to make IgE, the allergic antibody, versus IgG, the other type of antibody? And a lot of factors seem to be involved in this, but one of the concepts which came about a few years ago is called the Th1-Th2 hypothesis. And what this means is the cells which control the type of antibody which is produced do so by making communication chemicals called cytokines. And they come in a number of families, one of which is called Th1 and one of which is Th2. The Th2 type of cytokines drive the immune system to making IgE instead. And so it's often thought that the reason why people start to develop allergies is because their immune system has become more Th2 than Th1.
And we hear a lot in the papers the idea that maybe growing up in a very sterile environment has something to do with allergies, and allergies are apparently on the increase in the UK. Is this actually true? Is there much scientific evidence for this?
There are a whole load of papers about this, and this isn't actually the subject of my personal research, but when I've read large overviews of the field, it seems that there is this idea running through them that clean living somehow predisposes you to allergies, and it is true that allergies are on the increase, but actually when we look at people's homes, there's just as many germs there as there used to be. The only things which seem to make a difference in the predisposition to allergies in terms of the environment are the birth order. Are you a first child, a second child, or a third child? The bigger the family, the smaller...
Who's worse off in the birth order, Carrick?
Me, the responsible older one, I'm afraid. So, my brother got the bike and the skateboard, and I got the rhinitis.
Look, we've got a stack of emails here. We've got Aaron's in Clearfield, Utah, says he likes listening on our podcast. I deal with allergy symptoms for a good portion of the spring and summer, and my question is, why does my sneezing, itchy nose and eyes go away when I lay down to go to sleep and while I'm sleeping? I hope you can answer that on a future episode. Thanks.
Well, it really depends what type of allergen is responsible for causing Aaron's symptoms, but it sounds like it's a type of pollen. And of course, when he's out and about during the day, then he's going to be meeting that pollen. And when he's in bed, he's likely not to. The exception for that is whether he or his partner has long hair. And I often find patients with pollen allergy have terrible problems at night because one of them has very long hair. And as you know, if you've got long hair, it's a complete static pollen magnet. So if you wash your hair before you go to bed, rather than when you get up in the morning, you can spend an allergy-free night without having a cloud of pollen around you.
Hazel in Norfolk says her husband developed an allergy to nuts at 32 years old. Is it common to get allergies as you get older, or is this more of a childhood phenomenon?
Well, children certainly do get allergy to nuts, and some of the allergies go away with time. Unfortunately, nut allergy tends not to. About 85% of children with nut allergy will have it for life. But it's not impossible to develop an allergy later in life, and I often get patients every week who say, well, why me and why now? I'm 30 or 40 or something like that. I'm afraid it just happens, but it certainly isn't an exclusion. So if you start to develop serious symptoms of an allergy in later life, get it sorted out, because it can be an allergy.
Here's a sort of converse. This is from Yumi, who is writing from Japan and says, I've been suffering from hay fever ever since I was in junior high school, but then suddenly 2 years ago when I was in university it was cured, or so it seems. Never had any medication or anything like that. What happened?
Well, presumably his immune system just got the hang of dealing with that pollen, and instead of making IgE antibodies against it, it presumably changed to making IgG. The other type of development which happens in the immune system is another type of cell comes along called the T regulatory cell, and that is allergen-specific but gives off cytokines, the communication chemicals which damp down the immune system. So whereas he used to have an allergic reaction, it may be that his T regulatory cells have now got the hang of controlling that, and that's great news for him.
We've got a quick question here from Brad Smith, who's in Portland in Maine, and he has two questions. The first one is Dr. Cat single? No.
Bet you wrote that.
I didn't. Thanks, Mum. No. And the second is, what is it about sleep that makes it so beneficial to us when we're ill? Are we better able to mobilise our disease resources? How is sleep related to the immune system and fighting off things? Anyone want to chip in on that? Any ideas?
Well, we have different patterns of hormones that go up and down during the 24-hour day, and some of the healing hormones seem to be involved in the sleep phase of the day rather than the daylight phase of the day. But we're mending all the time, breaking down bits of our body and rebuilding it as we need it.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
Samantha in Bar Hill reckons the answer to my teaser, which is what geographical feature does every continent have an example of except us here in Europe, is a... not going to say it. What do you think it is? Begins with a D. D something. That's your clue. John in Norfolk's definitely on the right lines. Now, Mark Booth has joined us from Cambridge University. He's an expert on parasites.
Hello.
Mark, parasites have to evade our immune system, don't they?
Indeed they do.
So how have they worked out how to do that?
Well, if you look at parasites, they are incredibly variable in the ways that they evade the immune system. Don't forget that we've co-evolved with parasites over millennium. Parasites have been found, for example, the eggs of helminth infections, which are a type of very successful worm infection, have been found in the faeces of animals living in the lower and middle Pleistocene era. So they've been...
So how old's that?
Well, that's trillions and billions of years ago.
Okay.
So they've been around a very long time. They've adapted to our immune systems, and we've learned to live with them to a large extent.
There's evidence, isn't there, that people that don't have parasites are less healthy than those that do in some respects?
Generally not. I mean, parasites are defined as being pathogens that cause harm to their host. So generally people who are infected with a parasite will suffer some ill health as a result. However, the essence of this discussion is whether or not parasites are associated with protection from allergy, and there is indeed some evidence that is the case.
Because haven't people compared, say, Ethiopia and the UK, and if you look at the rates of allergy in parts of Africa, you just don't find people with things like asthma and hay fever, like Carrick was saying.
Indeed, and within Ethiopia you will find that people living in urban areas have a higher incidence or prevalence of allergic diseases compared to people living in rural areas, and there's certainly a strong ecological correlation.
So what do you think's going on?
There could be many things going on. People who live in urban...
What do you think is going on, Mark?
People who live in urban areas have more televisions. They live a very different lifestyle. They're exposed to a number of different stimulants for the immune system than people living on farms. However, in terms of parasites, what it appears is that as people move from living in rural environment to an urban environment, they lose their parasites. People who are stuck in who live in the country certainly have high levels of parasitemia.
Now, what does that actually mean to the immune system, though? If you've got a body full of these things, how are they creating a sort of cloaking device so the immune system just does not see them? What are they doing?
Well, that's a good analogy. In fact, let's take a specific example. The schistosome worm, bilharzia as is also known. This is a worm parasite that lives in the mesenteric veins, that's between the gut and the liver. The parasite lives there for several years. In fact, there are cases of the parasite living for 20, 30 years maybe. It does this in a variety of ways. One of the ways it can evade the immune system for long periods of time is by coating itself in proteins that actually belong to the host. So it's a kind of stealthy cloak, an invisible cloak. One of the other ways in which it can evade the immune system is by sloughing off its tegument, its outer skin, so it replaces any damage that's occurring on a regular basis. And the other important way, which ties in nicely with the allergy, is that it induces these T regulatory cells in particular, and we think it's upregulating certain responses that dampen down those horrific immune responses associated with allergy.
Because if you look at the levels of the IgE that Carrick was talking about that drive the allergic response in someone like me with hay fever, in someone who's infested with the kind of parasite you were talking about, schistosomiasis, aren't their IgE levels through the roof? But those people don't have allergy.
Indeed, it's an interesting apparent paradox. I say apparent paradox because it's not a true one. In fact, what we think is happening is that the parasite is a potent upregulator of these Th2 responses. So you might ask the question, well, why don't people with parasites have allergies? But the key thing is that because the Th2 responses are also harmful to the parasite, as Carrick mentioned, we have IgE and histamine release that can certainly cause death of the parasite. The parasite has to down-regulate that, and it does that by inducing production of these T regulatory cells.
We'll come back to Mark in just a second because we have to check out in the meantime what's happening on the roads. So if you have any questions for us here on The Naked Scientist, 08459 25 2000 is the phone number. Text in on 07786 20 1960 or send me an email, chris@nakedscientist.com. We're also looking for your answers to what geographical feature does every continent have an example of except Europe. We've heard from Jeff, who's in Hildeberg in Germany, listening to us online. He's got the answer right. What do you think the answer is? 08459 25 2000.
Sorting out the sparks from the quarks. The Naked Scientists.
This week we're talking about the science of allergies, the immune system, parasites, and in a minute we're going to come back to Dr. Mark Booth to find out more about parasites and how they smuggle their way into our immune system. If you want to join in the last few minutes, get calling now, 08459 25 2000. We've had a call in from Jessica in Nayland, who's 100% allergic to onion, garlic, leeks, chives, and the rest of those kind of allium-based things. What is it about this family of vegetables that causes allergies, and isn't there anything she can do about it? Anyone any idea? Carrick?
It's not a particularly common allergy. I wonder whether she's had formal testing against that, because all those plants are quite irritating in their own right. If I peel an onion, my eyes and nose water. It's a bit like having an allergy, but it isn't really an allergy that's there. But she may or may not have had this proven by a proper laboratory test or a proper accredited skin test.
So, onions irritating generally.
Quick question for you, Carrick. Andrew in London and also Bethany in Portland in the US, both speculating on the same line, which was heard a report that bacteria in our gut and our immune system respond to the local environment. So is there any medical benefit from picking your nose and eating it, transferring regular samples of airborne bacteria and viruses to the immune system's training ground in the gut? What do you think of that?
I think we train our immune systems quite politely without having to do that.
Nigel's on the line. Let's have a quick chat to Nigel. He's in Northampton. Hello, Nigel.
Hello.
Welcome to The Naked Scientist. What do you want to talk about this evening?
I was thinking about the common reaction to allergy is a rash, and I wondered why there was a rash and what good did it do?
Carrot.
Well, a common reaction to allergy is probably more to have your nose run or to wheeze, but the same sort of process can happen in your skin, and that histamine is making the blood vessels leak out their fluid rather than the red cells in them, and that makes the skin swell up and go red.
So as Carrick mentioned, I think the mast cells that do this histamine release, they're also found in your skin, aren't they?
They're just under the skin. I think it's very important to realise, though, that quite a lot of people get hives or urticaria most days of the year. They have chronic urticaria, and this is not an allergy. But many GPs will look at them and say, oh, it must be an allergy because you've got the rash. It never is in that situation, and it's worthwhile seeing an immunologist, allergist, and getting that sorted out.
Quick go at the quiz, Nigel.
Yeah.
Here we go then. In describing their ideal man, women place the greatest emphasis on looks. Is that science fact or science fiction?
Fiction.
You're absolutely right. In recent surveys, looks actually came third when women were asked.
What was first, wallet size?
No, the first was intelligence. Intelligence was in second place. A good sense of humour came top at 98%. Cooking ability apparently only rated about 34%.
The global trade in chocolate is worth £100 billion, Nigel. Do you think that's true?
Yeah, probably.
Not quite right there. It's worth about £30 billion. That's 43 billion US dollars.
1 out of 2 puts Nigel in second place this evening. Let's return now to Mark Booth, who's joined us from the University of Cambridge. Mark, you're part of the Matt and Jeannie project, so what's that all about?
That's a charitable venture that we've started within our research group. The main idea is that we wish to support communities where we've been working. The group's been well established in East Africa for the last 25 years, and we feel that every time we go there, we owe the community something because of their cooperation. So what we're doing is we're trying to raise money for community projects. We talk with people in the communities, we liaise with them, they identify projects that they think are important to them, then we try and raise funds for them here.
And what are you currently working on? I mean, what's the key thing now to try and understand how you can borrow from biology and nick what these bugs have learned how to do, which is to switch off allergy from the body's immune system?
That's one of the things we're interested in. We work in Kenya and in Uganda, and we're involved in seeing what happens when we treat people for their parasitic infections. One of the things you might expect to happen is if you remove the regulation that the parasites are using to protect themselves, then you may find a rise in allergic responses, and you may find a rise in histamine levels and so forth. We're interested.
Does that happen?
It does happen, but there are a few big buts. First of all, because the parasite has been very successful while it's in existence, it's kept your histamine levels very low. When you remove the parasite, the histamine takes a long time to reach, say, European control levels, so you don't suddenly die of anaphylactic shock once you take the parasite away.
So are people actually doing trials now to understand whether it's possible to simulate that effect?
Yes. In fact, if we understand the idea that if you have a parasitic infection, you're protected from some types of allergy, then we can look at the work of, say, Professor David Pritchard up in Nottingham. He's actually involved himself in a clinical trial using hookworms to protect against asthma.
We had him on the show a couple of months ago, I think, and he was talking about some of the work they're doing. And again, it's not just diseases like allergies and asthma, but I think it's also things like rheumatism as well. Other autoimmune diseases may be damped down.
That's right. Parasites have been used therapeutically in trials against Crohn's disease and ulcerative colitis.
How does that actually work? Are they producing factors locally, or is this sort of manipulating the entire body's immune system? Because the diseases like joint disease and bowel disease, it's obviously very focal tissue that's affected. So is it just having, say, the worm, because people have fed worms to people with Crohn's disease, haven't they, and demonstrated they've improved. Is it just having the worm physically in contact with the bowel wall that has the effect, or is it something coming out of the worm into the bloodstream? The worm appears to be mediating local events at the bowel, because it will be inducing the upregulation of these regulatory cytokines like IL-10, and that just calms everything down so you don't get this overactive immune response against the flora in the gut. Thanks very much, Mark. Kat?
Okay, and just finally, before we come into the last minute of the show, we've had an email here from Maria Ramirez, who says she's listening to our podcast from exotic Waukesha in Wisconsin. She says she's actually listening to our podcast during her calculus maths class. Naughty Maria. She wants to know if we're going to do a world tour, because she would totally come. It would be great.
Are we?
I don't know. Are we? Anyone going to pay for us to go on a world tour?
We do a sort of virtual world tour from here in the studio. But look, we've run out of time. My massive thank you to Mark Booth and Carrick Sewell for joining us this evening on the programme to talk about parasites and allergies and that kind of thing. I'd also like to say thank you to our production team here at the studio. Thank you to Anna Lacey and Holly Barclay and to Petro Minch, who do an amazing job helping us every week to put this whole thing together. Next week, we'll be taking a look at nuclear reactors and finding out all about the science of nuclear fission and nuclear fusion. We'll also be looking at the biggest nuclear fusion reactor that we know about, our own sun, and asking how that works. And also, appropriately enough, considering the science of sunburn. And there'll be a great kitchen science experiment to explain how sun cream works. So, if you've got any questions about any of those topics in time for next week's show, then do email them to me. The email address is, of course, chris@nakedscientists.com. And if you'd like to show your support for us here at The Naked Scientists, then please consider voting for us at Podcast Alley, or you can nominate us for the 2006 Podcast Awards in the Science and Technology section. There are details on our website at nakedscientists.com. Now finally, the answer to this week's teaser, I asked you, what does every continent have an example of, except Europe? The answer was, of course, a desert. Thanks very much for listening, and until next week, goodbye.